Hello, my name is Amir Hossein Shabani, a PhD candidate at Oslo Metropolitan University in Norway, and my today presentation is about the preliminary structural survey of heritage timber log houses in Tonsberg in Norway. My PhD project is a part of a European Union funded project which is called Hyperion project, and it's a part of Horizon 2020 project. Hyperion is dedicated to investigating the vulnerability and resiliency of historic areas using innovative technologies such as accelerometer sensors, 3D laser scanners, drones, and hydrothermal sensors. There are 18 institutions around Europe that are classified in 11 work packages, working on different aspects of the project. And I'm working as a part of a work package 5, which is dedicated to multi-hazards modeling, vulnerability and impact assessment of the historic areas. Heritage structures are culturally, economically, and socially important to be preserved for the nations around the world. Timber, as the oldest organic construction material, is widely used in heritage structures, similar to masonry. Timber is more susceptible to environmental risks than masonry, bricks, or stone, and its behavior is quite complex. For other types of materials, modern preservation techniques can potentially be used, but in the case of timber, traditional techniques are recommended because of the susceptibility of timber to decay and the necessity of replacing members at given intervals. Log houses are one of the ancient timber structural systems. In a log house, the horizontal timber logs are laid on top of each other and the stability of the structure is provided by the corner joints where the wall planes interlock, as you can see in the figures. The log house system is used in northern European countries and in the central Alpine region, which also extends into several Eastern European countries. The technique can also be seen in Japan, China, and North America. The low heat conductivity of wood is taken advantage of in this structural technique for high insulation of the building, which is very important for countries with harsh winters. A comprehensive review study was done in order to investigate different types of methodologies for the conservation of heritage timber buildings. And finally, a methodology was proposed with the name of Hyperion, as you can see in the flowchart. For the first step of the methodology, we have the preliminary survey, which consists of visual inspection, geometric survey, and recording templates. And for the second step, detailed methods should be utilized, which consist of non-destructive tests, semi-destructive tests, and data analysis parts. Because destructive tests are not allowed on the cultural heritage assets. The next step is ex situ method, which consists of full-scale tests, experimental tests, and linear numerical analysis and nonlinear numerical analysis. And the loop, as you can see in the figure, should be followed to find the best retrofitting strategy for the heritage buildings. And finally, at the end, if everything is satisfied, the methodology is finished. In this study, preliminary survey of heritage timber buildings as the first step of the Hyperion methodology is done. The timber log houses are located in Tonsberg, as you can see, in the south of Norway. According to sagas, Tonsberg was founded in the Viking period at the end of the 9th century. Yet no archaeological discoveries have confirmed these sources. Today it is believed that the town was founded in the 10th century, which still makes Tønsberg among the oldest cities in Norway. Two case studies, as you can see in the map in the red circle, are selected: Fadium Storehouse and Hersted Loft, that are investigated in this presentation. The Hersted Loft, as you can see in the picture, is a storehouse originally located on the farm Hersted, 50 kilometers north of Tønsberg. The whole house was moved to the Slottsfjell Museum in Tønsberg, where it was restored in 1957. The lower floor is its original state and has been dated to 1407. Two supporting beams are employed and the main beams are laid orthogonally on them. All the roof systems, timber logs of the second floor are laid orthogonally on the main beams. However, due to the lower dead and live loads on the second roof compared to the first roof, those supporting beams have not been utilized, and the roof systems logs are laid on the main beams, as you can see in the figures. The area of the second floor is more than the first floor. The Fadium storehouse is the second case study with two stories, which is a log house covered by a coat of insulation because of its original use as a storehouse. The structure dates back as far as the 1750s, and it is constructed with small timber columns on a stone foundation. As it is illustrated in the figures, the floor system is laid on the shorter timber columns, which are on stone foundations. The main surrounding beams of the floor are simply connected to the columns without any constraints for the rotation. 3D laser scanners were utilized for the 3D geometric documentation of the case studies, which are faster and more accurate compared to the traditional geometric documentation ways. A total of 18 scans, 12 exterior and 6 interiors, were carried out for the case studies. The point clouds from each scan were merged in recap software, as you can see in the top figures. And after that, they were imported to the Revit software, and also the structure is modeled. At the bottom of the slide, you can see the 3D models of these two case studies. Performing non-destructive tests using 3D laser scanners is also investigated in this study. For this purpose, GeoMagic software package is utilized. As you can see in this figure, from the dense point clouds, a timber beam is selected. And after that, insignificant deflection in the beam can be detected in the figure. Moreover, deviations from a reference point and also protrusion in timber elements can be detected using GeoMagic Control X software. As you can see in the figure, it's an example from the Hersted Loft building. There are some future plans for these case studies that are presented in this slide. Now the accelerometer sensors are working to investigate the dynamic characteristics of the buildings. After that, a finite element model will be developed for the case studies, and finite element model updating based on the dynamic characteristics that are derived from the operational model analysis are needed to be done for the case studies. Moreover, long-term accelerometer data can be derived. For this purpose, accelerometers are installed for more than 6 months, and based on the data, the effect of environmental conditions on the dynamic characteristics of the buildings can be investigated. For this purpose, the data that are resulted from the accelerometers are combined with the data from the sensors that record the humidity and temperature in timber elements. Thanks for your time and consideration, and if you have any questions, do not hesitate to send me an email.